Okay, so a piece like this, anybody have any ideas where to start?
Draw a radius.
Draw a radius. You're going to make a right angle there.
Make a triangle.
How do we make a triangle out of it, though?
Connect the two.
Connect these? Okay. That is a triangle. Now, one thing that, the part that most people don't see here is this. This triangle. Anytime I have a slope relationship like that, I can find this angle. That angle is going to be found by redoing this triangle with the 1 and 4 like this. There's my right angle. Anytime I have an aspect ratio, it makes a right triangle, vertical and horizontal. Right? So I'm going to look for this angle here, and that angle is going to be the inverse tangent. Opposite side's the 1 and the adjacent side's the 4. Oops. Yeah, it's 14.04 degrees. So the big question is, how does that help us? Well, if that's 14.04 degrees, that makes this angle up here 90 minus 14.04, otherwise known as 75.96 degrees, which makes this angle here 14.04 degrees, which makes this angle here 14.04 degrees. Why? 90-degree angle here.
I got the 90 on the left. I got
Yep. 90 minus 75, 96 makes 1404 up here.
Right, but why did the potential?
Sausage triangle. The two radii have to be equal.
Why is it 90 and what?
90 because this is a radius to a tangent.
Oh, I was looking at your picture.
So what we have here, 14.04 degrees, 14.04 degrees. This one then of course is 180 minus 14.04 times 2. So 151.92 degrees. Correct? 70 millimeters, 70 millimeters. Because I have half the diameter for the radius. Makes this side over here the square root of 70 squared plus 70 squared minus 2 times 70 times 70 times the cosine of 151.92 degrees. Right?
Where are we trying to find
That length. This is our law of cosines, basically. This is our law of cosines.
Right?
Yep. Morning. Which gives us 135.82 or 818 we'll go. Millimeters. So that is our x that we were looking for, the distance across here. Correct? Okay. Now, to get y. Just like we did when we had the circle in the V block, we've got to look at pieces. I can find this piece right here from this triangle. I'll show you that in a minute. This piece right here is just the height of this triangle, which I can find by just cutting that triangle in half. Then, of course, this is just a radius, which is just going to be 70 millimeters. Right? So let's find this piece here out of this triangle. Well, this is going to be the opposite side. This is the hypotenuse. If I'm looking at just this green half triangle, correct? So that's going to be a sine. Sine of 14.04 degrees equals that opposite side over 70. Put this over 1, and I'll cross multiply and divide. So it's just going to be sine 14.04 times 70. 16.98 millimeters. Then this height here is going to come from this triangle. That triangle also has 14.04 degrees here. We can find this side. Anybody tell me how? Because then if I find that side, then I can use it to find this side. I got to know one side somewhere. And this is the side I'm trying to find. So usually you got to find a different side. I mean, hopefully it would be nice if that side just popped up from somewhere. But we can get this top side here though, because we know this is 135.8. We're going to call it 135.82 all the way across here. We're going to round that down. 135.82. And this is 72, so we subtract and divide the difference by 2. Will give us, each side has to be the same, right? So 135.82 minus 72 is 63.82. Divide that in half is 31.91 millimeters. So this is 31.91 millimeters. Does that make sense? We're at 31.91. So then this side over here, this would be the adjacent side, and this is the opposite. So we're looking at a tangent. Tangent of 14.04 is equal to our 31.91 over that adjacent side. So we will do this over 1. 1 times 31.91 is 31.91 divided by the tangent of 14.04. 127.60. So that's 127.60 here. So what we have is the 70 plus 16.98 plus 127.60. 70, 16.98, 127.60. Make sense? That adds up to 14.58 millimeters is the overall height of the Y. Not so bad. This is one of the easier ones I've given you for a while. But it's a matter of seeing the triangles. Seeing, and this is common, I give you that 1 in 4 slope. Whenever you see that, it should just be automatic. Let's cut a triangle somewhere and find that slope angle. Whenever you see that, that's just assume you're going to have to do it. You may not use the triangle, but put it out there. Because in 99% of the problems, you're going to need that slope angle.
So somewhere along the line, you're going to give us one with the slope angle and you don't do it?
Possibly.
Where are you going?
This is math class. Sarcasm is only appreciated from the teacher. These are circles. Yeah, pretend they're circles. This one here has a diameter. I actually wanted to do that. Before they put this duct in here, I wanted to have a post, like a banner, put on the wall. Because, just right above the whiteboard, the objects on board are not drawn to scale. I suppose I could just put it right out here, but yeah. Okay, let's say our diameter here is 80 millimeters. Our diameter here is 120 millimeters. I give you a distance across here of I don't know. Let's go 50 millimeters. And I'm going to give you a center to center distance of 150 millimeters. I want to know X, the distance all the way, overall length. I want to know Y, the distance, the length of that straight line. I want to know the perimeter. I want to know the area. Where would I start with all this happy crap? X, most likely.
And don't ask why.
Clever.
That was a joke on the internet. Don't know where my X is and don't ask why or something like that.
There's where my triangles will most likely come out. I know that this is 50, this is 50, this is 40, this is 40, this is 60 and 60. I know this angle and this angle will be equal, this angle and this angle will be equal, right? If I want to, now I can cut each of these in half, find these angles, find that distance, right? So here's what I want you to do. I'm going to call this distance A, this distance B. I'm going to give you a couple minutes in your notes. Find A, find B. So, on this side over here, what we're looking at is a triangle. This is 25 and this is 60 here, right? So we're finding this was our B. Yep, this is our B. I'm also going to find this angle while I'm at it. So B is just going to be the square root of 60 squared minus 25 squared. Once we learn the trig, a lot of people tend to forget about some of the simple little rules that don't need trig, like the Pythagorean theorem. So 54.544. This angle here, that's the opposite, that's the hypotenuse, so it's going to be an inverse sine, 25 over 60. .62 degrees. On the other side, this is still 25 here, still half the 50, but this is only 40 now. It's out of the smaller circle. So this side's the square root of 40 squared minus 25 squared. Which is going to be 31.225 millimeters. This angle here will be the inverse sine of 25 over 40. .68 degrees. So now we can find X rather quickly. Now we can find Y. X is pretty simple, right? X is just the 150 plus 40 and plus 60, right? X is 250. Right?
Remember at the beginning of the year when you had to do stuff.
This seemed tough then, didn't it? Yeah.
Just find X.
Just find X, yeah. Now to find Y, we're going to take the 150 and we got to subtract 31,225 and 54,544. Those combine to give us 85.769, right? Subtracting that from the 150 gives us 64.231 millimeters is Y. Right? Now to find perimeter, it's all a matter of angles. We don't really care about these angles here. What we really care about is these angles out here. But this angle right here, I'm actually going to do the double angle, is going to be double the 24.62. So it's going to be 49.1 or 49.24, correct? So this whole thing is 49.24, which makes this out here 130.76 degrees. Add up to 180, or no, not 130.
I was gonna say,
360.
360.
That should be 210, right? Does that sound better?
Not 180.
It's not 180, it's 360. It's a full circle.
Calculator needs to be better.
Yeah, it does. I think it's a wet cell, not a dry cell, and it's been dry too long. Now over here I have the 38.68, which when I double that is 77.36 right here. Which means that this out here is 282.64, correct? You'll trust me, okay. Well, now the rest of it, the area and perimeter, are pretty simple. Let's do the perimeter. 282.64. That diameter is 80, so it'll be 80 times pi times the 282.64 is going to find that arc around this circle here, all around here, right? What do you get?
Oh, diameter.
80. $197.320. 3199, so 320. Over here, that's 120 times pi times that angle was 210.76 over 360. Let's go to what is your problem?
Battery is up. Put on it.
220.707. Plus 64.231 and 64.231, right? 231 times 2. 128.462. So we add this up. We got 9, 8, 14, 16, 14, 546.489 millimeters. Is that what you come up with? No, something's off. I think I'm right.
Seriously?
Yep.
197.320.
Yep. 220.707 And then 64.231 times 2. 231. 64.231 times 2. 546.489. Is that what you got now? 546? Okay. That is our perimeter. Did you get what you need off of there, Eugene? You need to go back up.
I got it.
Where did I get?
Where you wrote down where you got the 64, which
Okay. So that was the 150, which goes center to center, and I subtracted my A and my B. So I subtracted 31.225 and 54.544. So that's perimeter. That seems like it should be a lot worse, doesn't it? Area. I'm going to start with the easy piece. This is 50 by 64.231. So 50 by 64.231 equals 3,211.55 millimeters squared. Then over here I got the 282.64. The 360. That is an 80 diameter, so it's a 40 radius. So 40 squared times pi, or pi times 40 squared, radius squared times pi, times my 282.64 over 360. $3,946.40. Millimeters squared. And then I have 60 squared times pi times that angle over 360, which was 210.76, right? So 60 squared times pi times 210.76 by 360. 6621.22. Now I'm not done yet. I still need these triangles here. This one's going to be 50 times 54.544. Over 2. Should give us 1363.6. The other one's going to be 50 times 31.225 divided by 2. $780.63. This is the base of 50, and A is the height. The 31.225 is the height. So now I got some addition to do here. I'm going to shrink this down so I can get them all on one page. Easier to add if I can see them all at once. Maybe. So let's see. 5, 7, that's a 0. Here the 1, 10, 12, 18, 24. Carry the 2, 3, 9, 10, 13. Carry the 1, 2, 6, 8, 14. 2, carry the 2. 4, 13, 19, 29. Carry the 2, 5, 8, 14, 15. So 15,923.40. Does that look right? Looks like it should be way more difficult than that, doesn't it? It's just a matter of finding the pieces. What do you guys think? Think you can do it?
Time to go home.
Time to go home. You are an optimist today.
No, I know what kids would say. What do y'all think?
There won't be a quiz
All right.
today.
Ooh. No, it's the exam. Usually you get mad at me for saying that. It's the exam.
You guys are cynical.
Exam, that's a quiz. A judgment on skill.
I think math has turned you guys bitter. There's a worksheet I'll hand out. I'll leave that up while Bruce is. You got her copy down, or you still need some time? I'll leave it up for a minute. Want to be Dustin's keeper again?
Yeah.
Hey, Russell, I don't think he's a keeper anymore.
Oh, this looks fun now that we know how to do it.
Yeah, this one should be kind of simple. I actually gave you the X dimension this time instead of the center to center dimension, so it's actually even easier. So don't miss that I actually gave you slightly different dimensions. What's that?
You didn't give us, Ashley gave us the.
I gave you the straight line distance instead of giving you the center to center distance.